Have you ever thought about what would happen if an AI could teach another AI? It sounds like something straight out of science fiction, right? But it's actually a very real solution to one of the biggest problems in AI today. In this explainer, we're going to dive into some incredible research that shows how one AI can help another learn better, especially in the world of education. So let's get right into it.
Everything really starts with this one simple but absolutely critical question. You see, AI models, especially the ones we use today, are basically data monsters. They learn from examples, and if you can't feed them enough good quality examples, well, they just can't do their job. And this isn't some far-off future problem. It's a massive bottleneck that's holding back progress right now.
And there's almost no field where this data hunger is a bigger challenge than in educational technology. AI has this amazing potential to completely change how we learn, but it keeps hitting the same wall.
Just think about AI tutors. These are tools designed to give students personalized feedback on their writing, anytime, day or night. The promise there is just incredible. But for it to work well, the AI needs to have seen thousands and thousands of examples of student work. The problem? That kind of data is really hard to get. It's often scarce, it's private, and it's a huge headache to collect. And it gets even more complicated. Even when you do have the data, it's usually all out of whack. So imagine you're teaching an AI to analyze essays. You might have thousands of sentences that are just simple descriptions, but maybe only a few that show real deep analysis. So the AI gets great at spotting the common stuff, but it completely whiffs on the rare and often, the most important categories. That's called class imbalance, and it creates a biased and frankly, a much less useful AI.
So how in the world do you solve a data gap and a bias problem at the exact same time? Well, this is where this new research gets really, really clever. The solution is something called LLM-driven data augmentation. And the idea is just brilliantly simple. You take one of these super powerful general-purpose AIs, like the kind that powers things like ChatGPT, and you basically turn it into a data factory. You ask it to generate brand new, artificial, but totally realistic examples of student writing, specifically for those rare categories where your data set is weak. It's like one AI is creating a better, more complete textbook for another AI to study from.
Now, this is a huge leap forward from the old ways of doing things. Before, data augmentation was kind of clunky. You might just swap a few words for synonyms or translate a sentence to German and back again. The results were often really repetitive and didn't really add anything new. But an LLM? Man, it understands context. It can generate completely fresh, rich, and diverse examples that are way more valuable for training. And this isn't just some vague, hey, let's try this kind of idea. The researchers laid out a very specific, repeatable methodology to make this work. They call it their 5-stage pipeline. It's basically a blueprint for success. So here's the quick flyby. You start by generating a first batch of data. Then you get smart and select some specific examples to focus on. You create more data based on those examples, you adapt the results to make sure they're high quality, and then, and this is the really cool part, you can loop the whole process to make the AIs smarter and smarter over time. And here it is, the full blueprint, right from the paper. Now I know it looks a little complex, right? Don't worry about trying to follow every single arrow here. The main thing to see is that it maps out a clear, logical process from start to finish. This is the engine that makes the whole thing systematic and repeatable.
So, the most crucial part here is this self-improvement cycle. This is one of the key best practices that came out of the research. Don't just generate a bunch of data once and call it a day. No, you generate, you test, you find the AI's weak spots, and then you generate smarter data to target those specific weaknesses. It's all about letting the model learn from its own mistakes.
Okay, so that's the theory. It sounds great on paper, but the big question is, does it actually work? So let's move on to the case study and see how this blueprint held up when they use it on real student writing. To really put this thing through its paces, they tested it on 3 very different data sets, which you can see here. They used reflective writing in both German and English, and then a totally different task, argumentative writing. This was a great way to really test the versatility of their approach. All right, let's get to the juicy part, the results. We'll start with the German reflective writing dataset.
And boom, check this out. That first bar on the left, that's the baseline. That's how the model did with no help at all. But as they apply the different stages of their pipeline, you just watch that performance climb, going from an accuracy of 0.55 all the way up to a peak of 0.61. That is a really significant improvement.
So it worked in German, but did the same thing happen in English? Let's take a look. Yep, it absolutely did. We see another clear win. Here, the baseline performance was already a bit higher, but the augmentation pipeline still gave it a solid boost, pushing the model's accuracy from 0.73 up to 0.77. That's 2 for 2. Okay, time for the final test. What happened when they applied it to a completely different style of writing, those persuasive essays? And what do you know? The pattern holds. Now, this was a tougher data set. You can see the baseline accuracy was lower at 0.44. But once again, the method worked, consistently pushing the performance upward to a final score of 0.48, a perfect 3 for 3. So the numbers are clear. The method works. But let's zoom out for a second and ask, what are the real-world implications here? Why does improving an AI's accuracy by a few percentage points actually matter so much for learning? Let's just boil it all down. What should you take away from all this? First, we've seen that these powerful LLMs can actually solve the data scarcity puzzle for educational AI. Second, this isn't just theory anymore. We have a practical, 5-stage roadmap that we know works. And third, and this is the whole point, this all leads to building better learning tools. We're talking about AI that is more accurate, more effective, and a lot more fair for every single student. And that's really the ultimate goal here. By balancing the data, we create an AI that can understand and give feedback on a much wider variety of how students express themselves. It means building tools that don't just cater to the most common way of learning, but can recognize and support the needs of every single student. As the researchers themselves put it, their work provides concrete insights and best practices. And they're honest about the trade-offs, too. For instance, just generating way too much synthetic data can sometimes dilute the original signal. Finding that perfect balance is a key best practice that this paper really helps to shine a light on for anyone building the next wave of educational tech. You know, this research was all about student writing, but the core idea of one AI generating targeted data to teach another AI, that's an incredibly powerful concept. It just makes you wonder, what other fields could this unlock? Medical diagnosis, scientific discovery, climate modeling? It really feels like we're just scratching the surface of how AI can help bridge its own data gaps. And honestly, the possibilities are just fascinating.